Okay, so in this week's videos, we're going to start taking a look at more than one event and how to find probabilities of two subsequent specific events in a sequence. So here's our trial that we're going to be working with. It says roll a six-sided die and then flip a coin. The probability we're going to be interested in here is getting a 6 and then getting a tails. So we can see that this is no longer one specific outcome. We have two things that are happening. So we're going to roll a die and we want to get a 6 and then we want to get a tails. So we're going to create a tree diagram to help find these probabilities. So when we roll a die, what are the different outcomes that we can get? We can get a 1, a 2, a 3, a 4. We can get a 5, or finally we could roll a 6. So this is just our first event. Then we're going to flip a coin after that, and we could get a heads or a tails. So from each of these branches, we could have a heads or a tails. Again, we went through probability trees in a previous video. I'd encourage you to go back in the playlist if you're having trouble getting these tree diagrams created, but this is going to have all of the different possibilities. So you can see, like, let's see right here, this would be the probability of getting a 1 and then getting a heads, right? Something like this one right here is this one right here is getting a 4 and a tails. So it says getting a 6 and then getting a tails. Let's look through here and let's try to find that. Can you see that this is the case? This is the case where we get a 6 and then get a tails. And if you count on the bottom, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different branches from the trees, or 12 different outcomes. And how many of those are the one we're looking for? There is only one time where we roll a 6 and get a tails. Now I want to show you, look at this. What is the probability that you roll a die and get a 6? Well, that we learned in a previous video is 1 out of 6. What's the probability that you flip a coin and get a tails? That's 1 out of 2. Let's take these fractions over here and take a look. So the rolling a die and getting a 6 is this. The flipping a coin and getting a tails is this. And the probability that we ended up with when we looked at the whole thing over here was 1 out of 12. Anybody see? Think about it for a second. What would be the operation between the 1/6 and the 1/2? Hopefully you see, maybe you don't have a lot of experience, but one thing to note is if you multiply 1/6 times 1/2, you will get 1/12. The next one says get a number less than 5 and then get a heads. So I'm going to change over to red so we can take a look. Get a number less than 5. So where are my numbers less than 5? It's right here. 1, 2, 3, and 4. These are all the numbers less than 5. And then the times where they get a heads, that's this one, this one, this one, and this one, right? So you can see that there are 4 of those out of 12, right? So the probability that you get a number less than 5 and then get a heads is 4 out of 12. Now we could reduce that fraction. 4 out of 12 reduces to 1/3. You can use your calculator to help you reduce fractions if you're struggling with that. Now, just to bring this idea home, let's take a look. The probability of getting a number less than a 5, we said that that was 4 out of 6. The probability of flipping a coin is 1 out of 2. So take a look at this. If we do 4 out of 6 times 1 out of 2, to multiply fractions, you multiply the numbers on the top and the numbers on the bottom. 4 times 1 is 4. 6 times 2 is 12. So this gives us 4 out of 12, which reduces to 1/3. So this is going to be way easier than us trying to do a tree diagram every time. So let's use this idea, which we call the multiplication rule, to do this last one. So it says find the probability of getting an odd number and then getting a tails. I'm going to give you a second. Why don't you hit pause on the video and you try to figure this one out. Okay, so hopefully we've got this figured out. The probability of getting an odd number, how many odd numbers are there? Well, there's a 1, 3, and a 5. So the probability of getting an odd number is 3 out of 6. What's the probability of flipping a coin and getting a tails? It's 1 out of 2. So to get the probability of getting an odd number and then getting a tails, we multiply those probabilities. 3 times 1 is 3. 6 times 2 is 12. 3 out of 12 is going to reduce to 1/4. These events up here, I want you to think about flipping a coin and rolling a die. Does the probability of rolling a die affect the probability of flipping a coin? I don't think they have anything to do with one another, okay? One's not affecting another. So these are called independent events. And given any random procedure, two or more outcomes or events of the procedure are called independent if the occurrence of one does not affect the probability or occurrence of the other one. So again, flipping a coin has nothing to do with rolling a die. Think about it in this next one. So if events A and B are independent, the probability of A occurs and then the probability of B occurs. We're going to do what we did just in the last problem. You just multiply their probabilities. There are lots of things that are independent. One thing to note about independent is these, if you have two things that aren't really related, you know they're going to be independent. Things like drawing a marble from a bag or things of that nature, what you're looking for trials that are independent are usually the term with replacement. And this is a key word here. You want to know with replacement means that you're going to reset the probability every single time. And we're going to look at an example, I think, today where we see that's the case. So rolling a die 4 times and getting a 6 all 4 times. Sorry, back it up. Rolling an 8-sided die 4 times. Some people didn't know in my class earlier that there were such thing as 8-sided die. So here's a picture right here. These are what 8-sided die look like. You can see that they're numbered 1 through 8. So it's finding the probability of getting 6 4 times in a row. So there are 8 sides on that die and there's only one number 6. So the probability of getting a 6 on the first roll is 1 out of 8. Times the second one is 1 out of 8, times the third one is 1 out of 8, times the fourth one is 1 out of 8. Sorry, that should be an 8. Okay, so what are we going to do with these? The words and means multiply, right? So what this is this ends up being 1/8 times 1/8 times 1/8 times 1/8. But you might know we have a nice way to write that, a little bit nicer way to write that. When you have repeated multiplication, I'm going to put this in a set of parentheses. And we could raise this. How many times did we multiply it? We can see there are 1, 2, 3, 4. So we will raise this to the 4th power. Now, when working with your calculator, you're going to want to make sure you put parentheses around your fraction because you need to let your calculator know that they need to raise both the numerator and the denominator to the 4th power. When I do that, I get this number right here. Yours might look different depending, but please remember that 2.441, there's like an E at the end. You see this E, -4. So that E -4 corresponds to needing to move the decimal place over 4 places. So this would be 0.00024441, so on and so forth. Now, what happens if we wanted to write this as a fraction? You can try to use your F to D button, or in the 83, it's Math Enter Enter. This might work for you. This might not work for you, though. You might hit Math Enter Enter or turn it into a fraction, and it spits this decimal right back to you. So what do you do if you need to write it as a fraction? Well, one of the things you can do is you can actually evaluate the top and the bottom separately. So if we do 1 to the 4th power, 1 times 1 times 1 times 1 is still just 1. And then in the denominator, we just need to figure out what 8 to the 4th power is, and that gives me 4096. So it's a really small number, but if we needed to write it as a fraction, it would be 1 over 4096. Just be careful to the way that it's asked on a test or a quiz or in the homework. It's going to be specific in how it wants you to write that answer. Let's take a look at this next one, and it says, find the probability to get 2 all 4 times except for the 3rd time. So the probability of getting a 2 on the first roll is 1 out of 8. The second roll, 1 out of 8. The third roll, we don't want to get a 2. So how many other possible combinations do we have? Well, there's 7 other numbers. So the probability of not getting a 2 on the third roll is 7 out of 8. And then finally, we want to get a 2 on this last one, so that one's 1 out of 8. So this one, we can't necessarily, we might be able to use some exponents, but I think we're just going to write it out. 1 out of 8 times 1 out of 8 times 7 out of 8 times 1 out of 8. And then we're going to multiply the numbers. A nice way to do this, again, multiplication, we can just multiply the numbers on top. I don't even think I need the calculator for this. So 1 times 1 times 7 times 1 is 7. And then the bottom number, 8 times 8 times 8 times 8, we did that up here, didn't we? We found that that was 4096. All right, the last one, actually, we're going to look at two more. The probability that a person in the United States has blood type B is 1.5%. One thing you want to do right away is if you see this, if it's as a percentage, the first thing you're going to want to do is get this written as a decimal. Remember, we can go from a percent to a decimal by dividing by 100. We don't like doing math with percentages. We might write a final answer as a percentage, but when it comes time to work with these, whenever you see percents, it's a good idea to go ahead and get it written in the decimal format. So it says the probability of a person in the United States having blood type B blood is 1.5%. 3 unrelated people in the U.S. are selected at random. What is the probability that all of them have B negative blood type? Well, I like to go about this with any probability problem, and I'm going to do this a lot in the next video, by setting up multipliers. So how many things are we choosing? We're choosing 3, so I'm going to set up 3 fractions. And now, what is the probability that the first person has that B negative blood type? It's 0.015, right? And then the same thing for the next person. And finally, the same thing for the next person. Okay, so in this case, it's going to be, that's the same thing as 0.015 raised to the third power. 0.015 raised to the third power gives us that. And then again, be focused on this e negative 6. That's telling you you need to move that decimal place over 6 places. So 3.375 e negative 6. We have to move this 1, 2, 3, 4, 5, 6. This is where our decimal is going to be. You're going to fill in some zeros in that place. So this is going to be 0.1, 2, 3, 4, 5 zeros, and then 3, 3, 7, 5. Or, again, if you wanted to write that as a percentage, you would times that by 100, and you get 0.0003375%. So pretty rare to get 3 people in a row that have B negative blood type. All right, I think we're going to have to, well, we'll see what we can do. We might need to cut this video off a little bit short and do the next one in a next problem. But it says, what's the probability that none of them have B negative blood type? Well, this is the probability that they do, right? So if this is the probability that they do, remember that they don't, we have to do what's called the complement, where we do 1 minus the probability of A, or the probability that they do. So 1 minus 0.015 gives us 0.985. So there's a 98.5% chance that they don't. So what's the probability that none of them do? Well, it's going to be, this is the probability that the first person doesn't. And then we're going to do that 3 times, so we're going to raise this to the third power. So to find the probability that 3 people do not have that blood type is 0.985 raised to the third power, which is, we'll round this 4 decimal places. So this is 0.9557. So this is 0.9557, or 95.57%. All right, the last one we're going to do before we go take a look at the next section, which is dependent events, is if the probability of winning a particular prize on a slot machine is 0.029%, what is the probability of winning twice in a row? Make sure, again, I see this percentage. I need to make sure I get that written as a decimal. So as a decimal, this is 0.00029. Whoops. And then, again, I want to know, this is the probability of winning once. So the probability of winning twice in a row is this times itself, which is squared. So 0.00029, and then we will square this. That's going to give us a tiny number. Again, that means I need to move the decimal place over to the left 8 places, which is going to give me 0.0000000. 1, 2, 3, 4, 5, 6. There's 7 zeros, and then 841. So tiny, tiny probability. Again, if you need this as a percentage, you're going to multiply that by 100.